Hello students, how are you? So actually today is our last class for the crash course. I know that you guys are a bit worried, I think. So probably if you are watching this video, uh, all the very best for your next exam. Okay, right. Yeah. So thank you. Okay. Now, yesterday we have discussion section A. There are some problems based upon, tautomerism, name reaction questions are came, and some of the things we have discussed on graphite. Okay, then volume strength question. So there was one volume strength question which I have missed yesterday. That was like this question was very easy one, but okay. Okay. So the question they have given the volume strength. Let me show the Yeah. So the volume strength question has been asking. Right. This volume strength can be calculated by using this equation. 2H2O2 gives rise to H2O plus O2. So if you balance this one, you are going to get the number of oxygens have been balanced. So from this equation, we got to know that they are asking the volume strength for 30.36 gram liter. Okay, that is the question. So if the volume strength is given, find the volume. Okay, so find the volume they have asked. So how do you calculate this one? For 2 moles of, by applying the stoichiometry, 2 moles of H2O2, you require 1 mole of O2. That means for every 2 moles, you require 22.4 liters of volume, right? So that means like if for every 2 moles, right? 2 moles means what? 2 into what is the weight of a mole of 1 mole of H2O2? That will be 34. So for every 68 grams, you require 22.4 liters. So for every 68 grams, you require 22.4 liters. But the question asked for 30.36 grams. Okay, grams per liter. How much volume it is required? So it is very simple that you have to do the cross multiplication. That is how you are going to do. We are going to do that by 22.4 into 30.36 divided by 68. So if you solve this equation, you are going to get 10 point something. So the answer is 10 volume. So this is the question yesterday have been given, and I couldn't answer that one. I couldn't recall that. So I hope now you guys can solve this question easily. I don't think so any difficulty is there. Okay. Yes. So now we are going to discuss about question number 86, right? So if you see the question number 86, what is the question they are asking about? The pi bonded organometallic compound, which has ethene as one of its compounds. So a pi bonded organic metallic compound is means they are asking about coordination compounds. Example question. So they what is the first thing they have asked? They have asked about. We'll go this way. Just a moment. First, they have asked about Jesus salt. So Jesus salt is basically potassium and platinum will be there, and 3 chlorines and square types of C2H4. So this is the compound where you are having. So the structure, if you want me to draw the structure of it, so the structure will be like this: K plus chlorine, platinum, chlorine. It similarly look like a cisplatin, but the one bond is bonded with the ethene. Okay, so the one bond is bonded with the ethene. So this is pi bonded. Okay, we can say pi bonded ligand, which is forming a metallic compound. So you can say this is metal and this is pi bond. So metal pi bond is called as organometallic bond. So this is an organic compound and which is possessing pi bond between them, and it is forming a bond between platinum and ethene. So we can say from this particular step, this is a pi bonded metallic organic compound, organometallic compound. So the Jesus salt is itself ethane it consists of. So this is Jesus salt is the answer. So you may also ask about ferrocene. Ferrocene is the 5-membered rings, okay, present over here. So if you take 5-membered ring and ferrocene will be present, another 5-membered ring. Okay, so this is how the ferrocene will be look like. And if you want to write the formula of this particular compound, that will be Fe. Yeah, so that will be Fe n square. Okay. So n to the power of 5. Why I am writing n5? Because this is 5-membered ring. So n power 5 means 5-membered ring of what? C5H5. Okay, C5H5 twice. Okay, so this is how the bond is forming ferrocene, right? So ferrocene will be like this, but it is forming sigma bond with the metallic compound. But will form, whereas Jesus salt will form organic compound, okay, organometallic compound. Another one is dibenzene chromium, same as ferrocene, you are having dibenzene, again that will be N6, okay. So how do you write that one? So dibenzene chromium will be like, okay, this is Cr N6 C6H5. Okay, I hope you understand this one. C6H1 has been bonding with this, right? C6H6 benzene, so C6H5 will be the answer. So next one is dibenzene chlorine, and another one is they have given uh, tetraethyl tin. So this is tetraethyl tin. So we can say that you are having ethyl, 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 and ethyl. Okay, so this is forming a tetrahedral bond. So sorry, tetrahedral structure. So that's why this is tetrahedral linkage. Yeah, and next you can see from this. Let me erase everything so that. Yeah, so in you can see 85, 85, 87 question, you can understand. You can see the 85, 87. Name 3 lanthanides which show +2 oxidation state. So +2 oxidation state can be shown by. So generally these lanthanides will show +3 oxidation state. The common oxidation state of lanthanide is +3. But still some of the compounds will show +4 and +2, +4, +2 and +4 oxidation state. This is due to the stable configuration like 4F0, 4F7, and 4F14. So if you see the 4F0, cerium is going to form +4 oxidation state for the 4F0. And whereas if for 4F14, ytterbium, if you can say capital YB +2, okay, which can exist in the 4F14, it will become stable. So that is why instead of getting +3, they will get +2. So simultaneously for terbium, Tb is also existing in +4 state, and europium, U+2. Okay, europium will also exist in the +2 state because they will form half-filled configuration. So half-filled configuration means stable configuration. Like if you see in case of chromium and copper, same half-filled configuration is stable for them. So that's why they will lose +2 electrons to form the uh, what we call that 4F configuration. So if you see the europium and terbium, these will possess +2 +4 because they are forming half filled configuration. And fully filled configuration also you can see ytterbium is forming +2 configuration, and cerium where they will completely lose the 4f electrons, which is loosely bonded electrons. So that's why cerium will form +4 oxidation state. But these are the some of the examples. And samarium will form +2 oxidation state. Ytterbium is forming +2 oxidation state, and europium is forming +2 oxidation state. And these are basically very good reducing agent, because how they will reducing agent, they will lose one more electron to form +3 oxidation state, which is the common oxidation state. So these are acting as good reducing agents, right? So these are the some good reducing agent. How they will reduce act as good reducing agent? They will undergo oxidation by losing one electron easily. Why they are losing? Because they will undergo into the common oxidation state, right? So if there are some good reducing agents, simultaneously there will be a oxidizing agents as well. True. There will be some oxidizing agents as well. True. Right. So now we are going to see the oxidizing agents. So the oxidizing agents are simply cerium and ytterbium. So these both are acting as very good oxidizing agents. Okay. So remember this one. They will lose one electron. That means which involves in reduction and form as oxidation state. So always remember that like +4 oxidation state, they will lose one electron. That means they will come to +3. Okay, so +3 electrons that will see they will gain one electron. Okay, they will gain an electron. They will become Ce+3, and this in also terbium is also become +3 electron by gaining one electron. Okay, by gaining one electron. So we can clearly say that which involves in reduction, they will act as oxidizing agents. Here also they will lose one electron, ytterbium, europium, and samarium. They will act as good reducing agents. So, but the question was asking what? What is the question? The question was asking name the lanthanides which show +2 oxidation state. So, samarium and europium and ytterbium will show the +4 oxidation state. Okay, so I hope you guys understand the question, right? And next one. Yeah, next you can say that uh, in a solution of CuSO4, how much time will be required to precipitate 2 grams of by the 0.5 ampere current. So they are asking the question for Cu. They are asking the question for CuSO4. Okay, which is going to form Cu+2 oxidation state. Okay, so that means what? Copper will be present in +2 and sulfate will be present in +4. So that means what? It will, it required 2 electrons, okay, to form copper. So we can clearly say from this example, so the how much charge, how many electrons are required? 2 electrons to produce one 1 mole of copper. So we can also say that 2 mole of electrons is required to produce 1 mole of copper. Okay, so from this equation, we can conclude that we know 1 mole of electron is 1 Faraday. 2 mole of electrons means 2 Faraday. 2 Faraday is required to produce 1 mole of copper. Now tell me what is the mass of copper here? What is the mass of a copper? What is the mass of 1 mole of copper? The mass of 1 mole of copper is 63.5 grams. So it is pretty clear that 2 Faraday charge is required to produce 63.5 grams. But the question they are asking about to produce 2 grams of copper. So to produce 2 grams of copper, how much charge is required? That we have to find. So then Q will become, okay, so then the Q will become what? 2 into Faraday into 2 divided by 63.5. And we already know that Q is equal to IT. Okay, and we know I has been given, that will become what? 4F by 63.5 is equal to I is given as 0.5 into T. Then T will become 4F by 63.5 into 0.5. So if you calculate this one, you are going to get the answer. So what will be the answer? You calculate and you can find it out. Just let me check. The answer will become Okay, the answer you are going to get will be 1. This is the answer you are going to get. Okay, so these will be calculated in the second, so that is why you don't need to worry. So the answer will be 1 to 120 12,157 seconds. Okay, 12,157 seconds is the answer. So can you answer question number 89? Question number 89 is another easy question. So that is weight in grams of a copper is deposited, okay, is deposited in a copper voltmeter when an electric current of 2 ampere is passed for 2 hours. If 1 ampere of electric current is passed for 4 hours in the same way, in the same voltmeter, copper deposited will be. Okay. So to understand this question, we need to know this question again. So I will read it out. Okay. 4 gram weight of copper is how much? W. Okay. So you can see from this one. Okay. Weight of copper is W. Okay. So you can see the question now. Weight grams, W grams of W grams of copper is deposited in a copper voltmeter when an electric current of 2 ampere is passed. So we don't know. So we can say that W grams of copper has been deposited, okay, on copper voltmeter. So how much current it took? 2 ampere, and how much time they pass? 2 hours. And same another case, same voltmeter they have kept, okay, but this time they have passed the current is 1 ampere and the time they took for 4 hours. Okay, so they are asking you how much weight will be deposited on this. So we know that W is equal to ZIT is the relation to find the amount of substance that deposited. So let's suppose if you say W is equal to W1 as a same voltmeter copper. So that's why we can say that voltameter, not voltmeter, voltameter. That's why we can say Z will be remain same. This is I1 and T1, and another will be W2 Z into I2 into T2. So just take the ratio of them, that is W1 will become W, W2 will become simply W2, and I1 is how much? 2 into I2 will be, T2 will be 2, and I2 is 1, and T2 will become 4. So if you take W is equal to 4, so both will cancel, so W2 will become W. So the answer is W. So very easy questions. Just you need to understand what are the equations they are asking. Just go with the basic things. So always remember, we have to know that how many moles of copper will be deposited. Usually copper will exist in a +2 oxidation state. That means 2 Faraday charge is always required to deposit 1 mole of copper. So if you are having aluminum, that means 3 Faraday charge is required to produce 1 mole of aluminum, because aluminum will exist in +3 oxidation state. Simultaneously, zinc 2 moles, Zn +2, it will going to exist. So just remember the whatever the common oxidation state of the elements, that those many moles are required. So those many moles of electrons means those many Faradays of charge, and you compare the charge with current and the time. So then you will get it. Okay, and next, if you see the top question, how many stereoisomers are possible for the following question? And this is our organic chemistry question. So stereoisomers means where you can find the chiral center. If one chiral center, two stereoisomers will be there. Two chiral centers, three will be there. So they're basically like cis trans, EZ. These are geometrical isomers. Stereoisomers like D and L, R and S configuration. Okay, these will be our isomers. Okay, let's see the question you can understand from this. Br CH2 CH, Br CH2 CH CH3, the CH2, CH3. So from this, we can clearly say we can find only one. Okay, here because the arrangement here is one hydrogen and one ethyl group, one methyl group, and methyl bromide group. So we can say one stereo center is there. One stereo center means they are not asking the chiral center or stereo center. They are asking about the isomers. So two isomers are possible. Got it? So two isomers are possible. From one stereo center, you are going to get two isomers. So basically, this question paper is quite not that much difficult. It is easy paper only, but I don't know what happened. Just give me a moment. Okay, right. So I think you can understand the question. Question number 91, same. Now they are asking about the stereo centers, not stereoisomers. They are asking about the stereo centers. So try to answer this question number 91. Take time and to answer this one. Okay. So the number of stereo centers presenting. So now you can see from this. Chlorine, on the other hand, it is bromine. So I would just written the opposite way. So they are asking about the stereo centers, means you should have four different groups need to be attached. So here you can see this particular carbon, you are having the same attachment over here, so same attachment. So this will be not a chiral center, whereas for this also not. And you can clearly say from this compound, two hydrogens are already attached. So we can't find any chiral center here. So the answer will become 0. Okay, so chiral center means all the four different atoms need to be arranged. So that is the reason we don't have the. Okay, next one. Silica is added to roasted copper ore during the extraction in order to remove. Very good question actually. So silica is used. Silica means SiO2, which is used to remove the ferrous oxide. Okay, which is removing as a slag FeSiO2. So their impurities which are present in the form of oxides can be removed by using, like by using silica. They will be help in removing the slag, which means they will remove the impurities. Okay, so they will remove the impurities, that is ferrous oxide, slag. The FeSiO3 is called as slag. Which factor is the most responsible for the increase in the boiling point of the noble gases from helium to xenon? So basically, even if you observe, generally all the noble gas compounds will not form any bond. Okay, noble gases will not form any bond. So what exactly happening for those things, like but xenon, if you understand, they will form multiple compounds. So we can clearly say from this one is generally these compounds which are having like helium, neon, argon, krypton, xenon, as they are not involved, but xenon is trying to form, xenon will form the compounds. You will see in group 8 of elements of your class 12. Okay. So, but what is going to happen down the group? Like there will be increase in the electron cloud. Okay, on the central atom. So, which eventually leads to the, we can say that polarizability. Okay, polarization will be increased because as the electron cloud density will increases, the polarization of the xenon will go on increases. If the polarization increases, it means itself it is having more stability. You required higher boiling points to break it. So that is the reason we can say that due to the polarization increase down the group, the boiling point will be higher. So the polarizability of xenon, okay, which will having increase in the polarizability on the xenon, it takes the more boiling point. And next, these are very, very most important reactions actually. 94. Xenon difluoride and xenon hexafluoride are separately hydrolyzed. Then Okay, xenon difluoride and xenon hexachloride are separately hydrolyzed then. So before going to do that, I would like to ask you to check the number of lone pairs in the both cases, the shape, the geometry, the hybridization, and the bond angles. The reason because if you see the chemical bonding questions, many of the questions are asked from this particular compound. Okay, so think once when you are answering this one. Okay, xenon difluoride, xenon hexafluoride. Okay, if you see xenon, how many valence electrons will be there? Yes, 8 valence electrons. In that, if two fluorines have already bonded, now how many lone pairs? One, two, three. Three lone pairs are present, and three lone pairs and two bond pairs. Three lone pair plus two bond pair. This will comes on sp3 dehybridization. So this will give you the linear geometry, and the bond angle will become 180 degrees. Okay, so these lone pairs will be present on the equatorial plane. Xenon, fluorine, fluorine, and here the lone pair will be present on the equatorial plane. Okay, so this is how the compounds will going to form. Next, if you see xenon hexafluoride, xenon is having 8, again 8, okay, and it will form 1, 2, 3, 4, 5, 6. One lone pair is present, and we can say 6 bond pair plus one lone pair. This will be sp3 d3 hybridization, and pentagonal bipyramidal. As one lone pair is present, it will be called as distorted octahedral. Okay, so XeF6 is a distorted octahedral, and this will be sp3 d3 hybridization. Okay, cool, right. Now we can see that, but the question was not, the question is asking something else. They are asking about what? They are asking about the reactions. Okay, when they are hydrolyzed separately. Hydrolyzation means what? They have to react with the water. So the moment when you react with the water, what will going to happen? XeF2 plus H2O gives rise to Xe plus HF plus half O2, half volume of O2 will become. So now balance the hydrogens if you can. So that means 2HF, 2 chlorines, 2 chlorines. So this is the equation. But if you are having HCS6 and if you are hydrolyzing with water, so this is 3 moles of water, you are going to get XeO3 plus 6HF. Here you don't get the half O2. So we can say from this one, hydrolyzer then both give O2 out, no. XeF6 give O2, no, and XeF2 does not, no. XeF2 will give, and XeF2 alone gives XO2. Yes, correct. XeF2 will alone gives O2. So these reactions are really must and important. So always remember while doing the questions. Okay. Which of the following is a thermosetting plastic? Thermosetting plastic, bakelite is the thermosetting plastic, and the rest of them not of the thermosetting plastic. So polymers, you will ask about the questions from what is a copolymer, what is thermosetting polymer, and they may ask you about nylon 6. They will ask you about the examples. So okay, so just go through the polymers chapter. This is another important chapter for your examination. Okay, and next, the sulfide not soluble in hard dilute nitric acid is. So yeah, so the sulfide not soluble in the hard dilute nitric acid, because all are metallic, has sulfides, and copper, zinc, and cadmium are not going to exist as metals at the or solids at the room temperature. The only compound which exists as a metal at liquid, the only metal which exists as a liquid at room temperature is mercury. So that's this mercury sulfide does not soluble at hard dilute because it will disappear, because at the higher temperatures it will not sustain. Okay, next one. Atoms of an element A form HCP, and atoms of C occupy 2/3 of octahedral voids. So whenever we talk about HCP, you should remember about CCP. So the number of atoms present in the CCP will be 4. And 2/3 of the octahedral voids means 2/3 of 4 atoms. Okay. occupy 2000 units, the general formula will become. So the general formula, what will going to become? C and A, let's suppose this is forming 2/3 and 2/3 of x, and this will become x, and C by C multiply with the 3, then you will going to get C2A3. C2A3 is the correct answer, which is the correct one, option C. So very easy, like the number of octahedral voids. If the number of atoms are n, then the number of octahedral voids will also become n, but the tetrahedral voids will become 2n. So this is another important thing you remember. Tetrahedral voids and octahedral voids may ask in your examination for sure. Okay, yeah. So then, if you see question number 98, which defect decreases the density of the crystal? Okay, so Franklin defect, Schottky defect, both A and B, and none of this. So very interesting question actually. This is comes from the solid state chapter where we discuss about the defects. Okay, so there is a defect decrease in the density. Okay, decrease in the density means what? Okay, if let's suppose if the interstitial, if I'm talking about Franklin defect, what will going to happen? Franklin defect. Franklin defect is also called as interstitial defect. Okay, Franklin defect is also called as interstitial defect. So what is going to happen? These cations will move to the interstitial sites, and they are just moving and they are creating a defect, but they are not taking outside of the system, outside of a crystal. So that is the reason what we can clearly say from this one. Okay, here it will move to the interstitial side, the density will be remain same. But whereas if you can see the Schottky defect, cation and anion, cation and anion, and cation and anion. If you see here, both cation and anion, both will be removed. Okay, cation and anion both will be removed. If both cation and anion both will be removed, then density the density will be decreased. Okay, the density will be decreased due to the removal of both cation and anion. So Schottky defect, where you will see there is a decrease in the density. Clear? Yes. So okay. Next. Which of the following will have the highest coagulating power for the AS2S3? Okay, sulfides. So always remember all the sulfides are negatively charged souls, and all the metallic hydroxides are positively charged souls. Hydroxides are like iron oxide and everything are negatively, oh, these are negatively charged and these are positively charged. Okay, these are positively charged soul. So the coagulation will done with the opposite charged species. So opposite charged species, you can see that aluminum +3 is there and sodium +3 is there. So and the rest of the others are negatively charged. And as it is already a negatively charged, the coagulation will be done. Coagulation means like coagulating, like combining, will takes place only with the opposite charge. So on this, we can clearly say that aluminum and sodium is the right answers in this two. And again, with the competition between aluminum and sodium, always remember coagulating power is directly proportional to the charge present on it. So more will be the charge, like +1, +2, +3, more will be the coagulation. So on that case, aluminum +3 will have more coagulation to the negatively charged soul. So another important type in this, remember, like they will give you the coagulating value. So remember, coagulating power is inversely proportional to coagulating value. Okay. So coagulating value is more, coagulating power will be less. So these kind of questions may come in your examination as well. Okay. And next, the gas which is expected to have a maximum value of KH. So we can say that KH, if you see, it is from the Henry's law, you have seen partial pressure is equal to Kh into mole fraction, or we can say solubility. From this case, we can say that if at a constant pressure, Kh is inversely proportional to mole fraction, and Kh, we can say that N, okay, number of moles by total number of moles. So then this will become N by N total by N of the solute. On that case, you can clearly say that it is inversely proportional to the solubility. So solubility, you have to check the solubility first. So solubility is depending on fraction, right? So which is solubility less soluble, that will have more KH value. So among this, which will be less soluble, we have to see the options first. So BH3 can be soluble, CO2 is soluble, which you used in cola, H2S hydrogen disulfide will give you a rotary cell, that is also soluble. Helium is inert in nature, so it is insoluble, or we can say lesser soluble. So lesser the solubility, more will be the KH. Option D is the correct answer, and the rest of them are. I hope you guys understand these questions. And I think pretty sure that you guys can do this type of questions whenever if they are coming in the examination. So before going forward, I would like to talk some of the topics which are really important. Okay, so remember in the chemistry in everyday life or environmental chemistry, in the environmental chemistry, so if you see the environmental chemistry, so in the environmental chemistry, we can see the topics are very important about the air pollution questions. The questions are usually coming from the air pollutions, especially they are going to ask you about the greenhouse gases. So this has been asking since so many days, or they will ask about which is responsible for the global warming. Okay, and they will ask about the acid rain. Okay, so these are some of the pollutants they will ask about, acid rain, air pollution, and water pollution. And water pollution, you will mainly talk about BOT, biological oxygen demand. Okay, and they will ask about the concentration in terms of ppm. Like if you see pure water, ppm will be 1 to 5 ppm. So this is another important thing. Okay, and next they will ask about on the ozone. Okay, so ozone depletion, why the ozone depletion is laying, who is the responsible? NO2 and O3 are the responsible for the ozone depletion. Okay, so and we can also use some of the other things like chlorofluorocarbons are also responsible for the ozone depletion. Okay, then you should know the reactions of them. Okay, you should know the reactions, what are the type of reactions. And another one is photochemical smog. Photochemical smog. So we know that photochemical smog is a mixture of fog and smoke. So in photochemical smog, you are having two types of smogs. One is oxidizing smog, and the other one will be reducing smog. Reducing smog. So in oxidizing smog, we are having the oxidizing agent like NO3 and NO2. And reducing smog, sulfides will be there. And along with that, CO2, gas, fume, smog will be there. Okay, and this will occur at humid weather and dry climate, and it will occur at cold and warm conditions. Okay, and you should also know that hydrocarbons are involved, and you should know about peroxyacrylonitrile, you should know about. Okay, so these are the some of the products that you are going to get. Formaldehyde. Okay, some of the hydrocarbons will undergo into photochemical smog to give this reaction. So, and another one, stratosphere. What is the gas present in the stratosphere? Stratosphere O3 is the major gas, and you should know the ranges. 0 to 10 will be troposphere, 10 to 50 will be stratosphere. So these are the some important things from the environmental chemistry, and I don't think so anything is the green chemistry. Just read about green chemistry. This is another area where you will get the questions from. Right. So now we also read about polymers. In polymers, what are the condensation polymers, copolymers, addition polymers? Basically, condensation polymers they are asking, like thermosetting polymers. They are asking about LDPV and bakelite. Okay, so their copolymers like nylon 6. These all questions are really important. Okay, then surface chemistry you should know about. From the surface chemistry, basically you should know about type of soils. So type of soils you should know, and the coagulating power just now we have discussed. Coagulating power just now we have discussed, that is another important. It is inversely proportional to coagulating value and directly proportional to the charge. So depends upon the type of soils. Positively होगा तो negative होगा, negatively होगा तो positive होगा. How do you identify positively charged soil? Metallic hydroxide. Okay, these are positively charged, and negatively charged will be like sulfides. Generally, all the sulfides are negatively, metallic sulfides all are negatively charged salts. They will be attracted by the positively charged salts. Okay, coagulating power, they will also ask you fluocculating value. Fluocculating value. Okay, fluocculating is also synonym of coagulatant. So that is also they may ask. They may also ask you about gold number. They will ask you about the gold number. So check the gold number. What is the gold number and how the gold number depends on this. Okay, so this is another one. Next, adsorption. What is the difference between physical adsorption and chemical adsorption? So where there are strong force of attraction and where there is a strong weak force of attraction, how the graph will proceed, and what which is a single layer and which is multi-layer. Okay, this is another important thing. And if you talk about organic chemistry, another topics like which are mostly important, aldehyde ketones. Okay, especially the named reaction in this. So if you know the Friedel-Crafts alkylation, Friedel-Crafts acylation, Riemann-Tiemann reaction, okay, and Riemann-Tiemann reaction, these are important. Gabriel-Thallamate reaction are usually used for the primary amines. So these kind of questions are also again important for your examination. And whereas what else? Yeah, in named reactions, nucleophilic addition reactions like 2 comma 4 DNP, CIPS base, these all are important. Itard's reaction and the reaction with the chromium or chloride. Okay, cumin reaction is also important from alcohol chapter. Then another one is acid catalyzed reaction. Acid catalyzed reaction. Okay, OMDM, oxymercuration, demercuration, HBO, hydroboration, and oxidation. These three are based upon the mechanism of Markovnikov rule, and this is follow anti-Markovnikov rule. OMDM, no rearrangement, but follow Markovnikov rule. Catalyzed reaction, rearrangement, follow Markovnikov rule. And we are having halogen and its derivatives, that is in that SN1 and SN2, SN1 and SN2, and E1 and E2 as well, E1 and E2. So you have to know these areas. If you see the bulky base, just go with the elimination. If you see the normal base like H2O and all, you are going to get SN1 and SN2. You should know SN1 depending upon the benzyl cation, stability of the carbocation, and allylic cation, tertiary and secondary and primary. Whereas SN2 will be like methyl halide, primary and secondary. Why not tertiary? Because of steric hindrance. And you should know the products. Here you will get a racemization product, both inversion and the retention product. Whereas in SN2, you'll get only the inversion product. Walden inversion, we call it. Okay. So these are the another important things you should know from SN1 and SN2. And another thing is like preparation of alkyl halides from alcohols. Okay, and which is the most commercial preparation method? SOCl2 will release the SO2 gas, and this is commercially viable and the best method for the preparation of alkyl halides. Okay, and next, mhm, this one I just take it out of the in class 11, the aromatic compounds, like basically aromatic compounds, you should recall the aromatic compounds, like don't by heart which compounds are aromatic. And you should know that it should be a cyclic one, and it should contains sp2 plain hybridized carbon, and number 3 conjugation is must. Okay, and number 4, 4n plus 2 pi electrons are must. 4n plus 2 pi electrons are must. There is no 4n plus 2 pi electron, then it's not an aromatic compound. What about anti-aromatic? First three are same and the last one will be 4 and pi electrons. Okay. So this is another important for our antimarconic acid. If both rules are failed, then that will become non-aromatic. Then this will become non-aromatic. Another important question, they may come in the examination. So think it, look over it again. And this polymerization, like from alkyne to how do you going to make benzene? Okay, so preparation of benzene from alkane and alkene and alkyne, these are also important things. And resonance is also another important thing. Soda lime reaction, yesterday only we have seen soda lime, that is NaOH in the presence of CaO. Okay, soda lime is simply used for the decarboxylation. Okay, decarboxylation. Okay, another important reactions. So if you go on like this, there are so many types of reactions are present. So I request you to just focus on what you have learned till now. Okay, if you are having any issues, you can contact the teachers. But I think this we are having another 1 week of time or 10 days, not exactly 10 days, some 1 week or 8 days time left. So ideally, my suggestion would be whatever the mock papers are there, try to solve them, especially solve from 2019, 20, 21, 22. These four papers are must. Without solving them, don't go to the exam. These papers are must. And if even if you don't know the answers, go through the solutions and by heart them, mug up and see those topics in the related topics. See those related topics. Let's suppose if the questions are asking from SN1 and SN2, just go through the E1 and E2 as well. Okay. And you are having short notes with you and do read. Okay. I hope you guys will do very well in the upcoming examination. So good luck, guys. Fine. So it's already 1 hour. So let me end the class.